All right, I want to go through this example as per request by a good friend of mine named Scott Knox. He wanted me, well, he actually didn't really request, but he mentioned that this is a cool way to prove that the derivative of sine of x is cosine x. I do agree. It's much cooler than the limit definition. The only potential issue is that you need to know what an infinite series is. So if you're in Calc 2, you may be asked this question. How can I prove this using a series? Well, let's just do it, right? So notice, well, here's the proof. Really pretty straightforward, I think. You just need sort of one piece of justification, but if you're in Calc 2, you don't even care about this. So I'll justify it though. So notice the derivative with respect to x of sine of x. I just need to differentiate the series representation for sine of x, the power series. So this is equal to the derivative with respect to x of the sum from k equals 0 to infinity of -1 to the k x to the 2k plus 1 divided by 2k plus 1 factorial. Again, if you've found the power series representation of sine, you realize it's this, okay? It's not too bad to discover using Taylor polynomial, right? Now, this is where we need the justification for just sort of the important step, actually. When can you interchange the derivative operator with an infinite sum? Only when this converges. This converges actually for all x. This converges on the interval -infinity to infinity, so we can absolutely exchange the derivative with the sum. In general, you cannot do that, so you need to be careful. So this is equal to the sum from k equals 0 to infinity of now, the other thing I want to mention is not only do I want to exchange the derivative with the sum, but I also can take any constants out of the derivative. Remember, the derivative is a linear operator. That means the derivative of a constant times a function is a constant times the derivative of the function. So you can take out these constants. All I care about is things that depend on x. So this is going to be -1 to the k, 2k plus 1, factorial times the derivative with respect to x of x to the 2k plus 1. Again, we can just pass the derivative through all this business. I mean, if you want to think about this in terms of what you do with the derivative, remember the derivative passes through a sum. So here's a sum, passes through the sum, although it has to converge. And it also absorbs constants. The constants just come right out. This is just a constant. It looks ugly. It's just a number, so it just comes right out. Differentiating x. Boy, oh boy. I mean, this is just the power rule. Easy peasy, right? So this is equal to the sum from k equals 0 to infinity. Bring the power down, subtract it from the exponent, okay? So just the power rule, -1 to the k over 2k plus 1 factorial. Now I'll take the derivative. Derivative is bring the power down, 2k plus 1 times x to the 2k. So just the power rule, right? Power rule. Which I proved in a previous video. So we can absolutely do that. And I proved it for natural numbers, which means specifically I can do it in that case right there, because those are natural numbers. Now, what? They're pretty much there. I mean, what does 2k plus 1 factorial? I used to teach Calc 2, and people would have trouble with this factorial thing. You do need to convince yourself a little bit. I want to do some cancellation here. Look at what I have here. I have 2k plus 1. I have 2k plus 1 divided by 2k plus 1 factorial. If you're new to this sort of thing, you need to write this out. This is equal to 2k plus 1 divided by 2k plus 1, 2k, 2k minus 1, dot, dot, dot. Right? I mean, think about what factorial means. It means take the number and multiply it by all the previous numbers, all the way down to times 2 times 1 times 0. I'm just subtracting one. 2k plus 1 minus the previous one. So 2k plus 1 minus 1 is 2k. Minus 1 is 2k minus 1. But look. Bam, bam. Numerator is 1 over 2k factorial. How nice. This is looking familiar if you know the series representation for cosine, right? So this is equal to the sum from k equals 0 to infinity of negative 1 to the k. I still have x to the 2k. And we just showed that this makes a cancellation of 2k factorial. Abracadabra, this is cosine x. Proof is complete. So which way do you like more? Using limit definition, which we resort to a damn trig identity, along with two special limits involving sine and cosine, which I also proved, or the series representation? Your choice, but you do need to remember this. If you go further in math, you need to remember this. This is because of convergence. Because of convergence. So if you go higher in math, you'll realize quite important. Cannot do it otherwise. Cannot do it in general. Like the video, subscribe, comment below. Tell me what you think. Except I don't want to hear anything about my hair. Alright, I just woke up. Whatever.